Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we've got an informative and practical topic for you today. Here it is. Use a constant scan rate with Horner OCS. All right, now wait a minute. What are we talking about here? Is this PLC scan rate? Aren't all PLC scan rates constant? What are we talking about? Well, hang with me. I told you this is a very practical topic. Let's break it down. For those of you who need a little refresher or don't know, we'll cover what is a PLC scan rate very quickly. And then, of course, we're going to dive into today's topic, which is using a constant scan rate. But what we're really talking about is lengthening your scan rate, which sounds totally counterintuitive. But trust me, there are scenarios where you want a longer scan rate, and we're going to show you how to do that, along with really describe some of those scenarios where it is useful. And when we show you how to quickly and easily extend your scan rate, and predictably, I should say, we're going to show you how to do it not only in the variable-based languages that we normally cover on this channel, but also with register-based advanced ladder. All right, and we'll have plenty of demonstrations for you. Here we go. Okay, so what is a PLC scan rate or a controller scan rate? Well, basically, it's the amount of time in milliseconds it takes to make one pass through the logic program, okay? And one pass through the logic program covers several different steps, and we've graphically shown them there on the right. You need to read your inputs. That's what the PLC does, of course, or the OCS All-in-one controller in the case of most Horner products. But anyway, the controller reads the inputs, then it solves the user logic, writes outputs that need to be changed, performs some housekeeping, and does it all over and over again. And as an example, your scan rate might be about 2.5 milliseconds, for instance. Now, generally, we think of PLC scan rates or controller scan rates of being constant. In other words, it always takes the same amount of time to go through the program. But that's not entirely true. And there's a variety of reasons why the scan can vary at least slightly from scan to scan. Different machine conditions can occur so that different portions of the logic or different instructions are being executed on a particular scan. Or in that housekeeping section there, that's where things like the network connections are taken care of, maybe reading or writing from a memory card or something like that. There's a variety of other functions that a modern PLC or a modern controller needs to take care of, which have an impact on the scan. Okay, but even so, most modern PLCs and all-in-one controllers have a scan rate of in the 10 milliseconds or less type range, unless you've got a really large program or maybe you're dealing with, a particularly basic controller. All right, so again, as I kind of hinted at as I broke down the topic today, what we're really talking about today is lengthening your scan rate to a settable value, okay? In other words, if you just let the controller do its thing, you might have a 2 or 3 millisecond scan rate, but there is some reason why you want that to be longer, say 10 milliseconds or 30 milliseconds or 50 milliseconds. Now, let's not confuse setting a longer, scan rate by, let's not confuse that with timed interrupts. Now, some of you are familiar with timed interrupts. What is a timed interrupt? Well, some PLCs have the capability to set what's called a timed interrupt. So that is a logic routine, okay, not the entire logic in the program, but a routine that is executed on a fixed periodic schedule. And these were really important in the days when PLCs and controllers had really long scan rates. 50 milliseconds was typical, or even 100 milliseconds was typical. And you had a routine you wanted to make sure got executed at least every 10 milliseconds, for instance. So timed interrupts were really important. And again, that ensured that a section of the logic was scanned much faster than the overall logic. That's not what we're talking about today. What we're talking about today, believe it or not, is actually taking what would normally be a shorter scan and lengthening it to a longer one. And why would you want to do that? Let's talk about that next. Well, basically, this is not something you have to do very frequently. However, there are a couple cases where it can be really useful. let's talk about process applications. Now, in some process applications, a longer solve interval on your entire bit of logic or your entire logic program may more closely match the time constant of the process you're controlling. So that could be a scenario where lengthening to a constant, longer periodic scan rate might be good. Now, keep in mind that if you've got a typical application, let's say that's doing some process control, like maybe you've got a couple of PID loops, for instance, and you're thinking, well, I've got a couple of PID loops, maybe I should make my entire scan longer to match my PID constant that I'm looking to use. That's not what we're talking about here, because in the PID instruction, the Horner PID instruction, for instance, in that instruction, you can set the rate at which you want that instruction to be solved. So if you want it every 50 milliseconds, or every 100 milliseconds, or even every 500 milliseconds, you can set that PID instruction to only execute or solve that frequently. So again, you don't need to lengthen the entire scan just to take care of that PID loop. However, the one very practical application that we're talking about where you may want to use this is in a retrofit application. So an application where maybe you've got a machine that's 10 years old and you're upgrading or updating the controller in that machine to a new controller that might have a scan rate that's 10 times as fast as the old one. Shouldn't be a big deal, right? You're getting faster. However, what you might find is after doing the upgrade, you might find that there are certain machine sequences that aren't happening properly or they're getting stuck. Why is that? Why would that be happening? Well, if there was a race condition in the original program and a longer scan rate in the original controller didn't cause that race condition to really show itself, now that race condition is an issue with the faster scan rate. Now, the best scenario in that case is to fix the race condition, right? That's the best scenario. However, we all know getting machines back up and running as soon as possible is a goal. And so one of the things you can do to quickly solve this issue is to lengthen the scan rate of the new controller. You know, if the scan rate of your previous controller was about 30 milliseconds and the new one is about 3, you could use the technique I'm showing you today to increase the scan rate in your new controller to 30 milliseconds. So that's really what we're talking about today from a practical standpoint. That's the one I've run into the most. Again, the best scenario is fix the race condition, but if you don't have time to do that in the short term, then you can at least lengthen the scan. Okay. So again, how are we going to implement that? How are we actually going to accomplish that? Well, basically what we do is we stretch out the logic portion of the scan rate to what our target is. So if we're looking for about a 30 millisecond scan rate, instead of just putting our logic in and letting it just execute as fast as possible, we can add a little bit of logic to the end of our user logic there that'll stretch it out to a desired level. Okay, so that's really what we're talking about today. So what might have taken 2 or 3 milliseconds will now take about 30 milliseconds. Okay, now how can we accomplish this? Well, that's what we're going to review today with the logic examples we have for you. But one thing I want to point out before we get there is that there are some system registers available in the Horner OCS that you can use to tell what the scan rate is. And the one that's most practical for this application is average scan, which is SR6, and that's the average of the last 5 scans, is what that system register will tell you. So that's what's going to be used in our example logic that we're going to show you next. And we're going to start with register-based logic because, let's face it, if we're talking retrofits, it would not be unusual that the program you're updating or the program that you're loading into your faster controller is a register-based program. So we're going to show you how to do that first, then we'll get to some of our variable-based languages. All right, let's take a look at this program, which is register-based advanced ladder, okay? And typically we would have in our main routine here, okay, in our main routine, this is where all the user logic from the existing program would be. So generally, let's say if you've got a 15-year-old program or a 10-year-old program that you are now going to be running on a much faster controller, and it turns out that it's not executing the way you expected, probably because of some race conditions, then what you're going to do is you're going to add some additional logic to lengthen the scan. That's what we're talking about today. So what I've done here is I've left the main loop alone, the main set of logic alone, and I've added something called constant scan, a constant scan routine. Okay, now, because this is register-based logic, we're posting this up on our website, so you can go ahead and download it and use it if you'd like. However, because this is register-based logic, you're going to have to make sure that you don't have any register conflicts between this added logic here and the logic that's already running in the controller that you're adding to. Okay, so almost certainly you're going to need to add or to change these register references here in this example program to make everything work the way it should into some unused register areas. Now, the good news is there's not a lot of registers that are used by this routine. So basically there are 6% R's and I believe 2% T's, and that's it. Okay, so not much to it here. So that's not a lot to have to remap. All right, now in the variable-based languages later on today, I'm going to show you how to use a user-defined function block, but those are not available with register-based. So here's the logic you're going to be adding. Again, you'll need to remap those 6 registers and those 1 or 2 T-bits to unused areas. But basically what's happening is, in this added routine, you're going to set your target scan rate. So if, let's say that the controller that you are updating, or I'm sorry, the program that was running in that old controller, let's say it was running at 25 milliseconds. Well, in that scenario, you're going to want to set this rung to set your target scan rate at 25 milliseconds. The default is 30. So to set it to 25, you would set this move block here with a source of 250 because it's in tenths of a millisecond. All right. So that would need to be changed after you've remapped your registers. Okay. And then basically by adding this routine, which we've got what here? We've got about 6 rungs. By adding these 6 rungs here, again, after remapping and setting your target scan rate, now you're going to have a result of a longer scan rate. Because what this routine is going to do is it's effectively going to be looping until the scan rate actually matches what it needs to match, okay? So that's basically the way this works. Now, this isn't perfect, okay? So it's going to take a little while to find the target scan rate, and then it's going to hover right around that scan rate. So if you set it to 25 milliseconds, it's not going to be 25.0 milliseconds every time, but it's going to be right around 25 milliseconds, you know, plus or minus about 1 millisecond on a continuous basis. And if you just really need to lengthen your scan rate to get rid of that race condition in the short term, this is a great way of doing it. Okay, so let's take a look at how this works on the bench. All right, here it is on the bench. And with my example program, again, that we'll post on our website for you tied to this video, you can see we've set a target scan rate of 30 milliseconds. All right, we've got an enable bit here that we've turned on to enable this constant scan rate. And you can see we're in the range of 29 to 31 milliseconds pretty continuously. Okay, so it's not exactly 30, but it's right around there, 29 to 31 approximately. Okay, now if I were to disable this logic, okay, you would see, oh, there's the scan rate when it's not in a fixed mode, and that is, you know, below 2 milliseconds. So you can see how there's a vast difference between having the logic enabled and having the logic disabled, okay? And so if you're trying to lengthen your scan rate for the reasons I've given you, this is certainly a way to accomplish that. Now let's show you how to do this same lengthening of your scan, but this time with our variable-based language options, including variable-based advanced ladder and IEC. All right, let's start with variable-based advanced ladder. So what we've done here is we've created a user-defined function block right here, okay, that incorporates all the logic that we basically just talked about with the register-based approach. And so this is a user-defined function block that you can import into your project that basically has 3 inputs. Okay, it has an input for, linking it to the system register that contains the average scan rate value. It's got another input, which is your target scan rate. Remember, that's in tenths of a millisecond, and that's another integer. And then we have an enable bit, which basically says, all right, I want to enable this particular user-defined function block. Okay, so that's really what we've got here. Now, if you were starting with an existing variable-based program, the first step you'd have to do is to actually import the user-defined function block into your project. How do you do that? Well, you go to Logic Modules, and you right-click and say Import Logic Modules. And then you navigate to the directory that has the UDFB file in it. And that UDFB file, again, is being posted on our website tied to this video. And then once you've imported that file, it's going to show up here, okay, under UDFB modules. It's also going to show up here in your project toolbox under UDFBs that you've imported, okay? Once it's here, then you can drag it onto your program like I previously did, and then assign your variables to the 3 inputs. Now, this is an unusual UDFB in that it only has inputs. It doesn't even have outputs. So the result is the same, right? Once you've set your target scan rate, okay, and you've tied the SR variable here as well, and you've assigned an enable bit, then you're good to go, and it's going to operate on the bench precisely the way that register-based example will. Okay, so this is what we need to do for variable-based advanced ladder. Now let's take a look at IEC, if that's the language you're using. Okay, so I'll take my IEC example here. And this is very similar. So effectively what we have here is somewhere at the end of your logic, you're going to want to incorporate, all right, the user-defined function block that we have created for you in IEC format, okay? And here is a structured text instruction for calling this particular user-defined function block, okay, as you can see here, all right? So we're basically calling or tying that user-defined function block to the system register. We're setting a constant for the target, okay, and we're enabling it through the always on bit, okay? So this is a very simple way of incorporating that, okay? And then if we take a look, we didn't do this for variable based, but if we take a look at the logic here for target scan rate, you'll see that we chose to write this user-defined function block in structured text because it was easy to do so because it involves looping. And a lot of times looping is a scenario where you want to use structured text for that. We could have used ladder as well, but again, structured text works well for this. So here's a routine written for in structured text, which is the user-defined function block, which is being called in a main loop module here. Now, of course, in a real application, in addition to this calling of the user-defined function block in this structured text routine, you'd also have other routines as well for other logic routines, maybe all in structured text, maybe a mix and match of different languages. Okay, so just like with variable-based advanced ladder, again, you got to remember the step of importing your user-defined function blocks. Okay, again, by right-clicking under Logic Modules, you can hit Import Logic Module. You then navigate to the file. Once you find the file, it's going to show up here. And then it's also going to show up over here in your toolbox, okay, as well. Okay, so hopefully this was a practical use of the technique to extend the scan rate or stretch out the scan rate for your application in those rare scenarios where it's extremely useful. Okay, that does it for our topic for today. Don't forget to participate in our case study program. If you've got a recent application with Excel Prime, Canvas, or OCS-IO, just follow the process of submitting a case study, and if everything goes as it should, you can get a free controller for your trouble. So definitely this is a program you should take advantage of if you can. Contact our marketing folks at the following email address on the screen. Okay, OCS training schedule moves on for 2025. We've got an advanced course coming up later this month. If you have time to adjust your schedule and get there, I would do so because we do have some open slots. Otherwise, plan on attending a course in the fourth quarter, either basic or advanced. Okay, still lots of opportunities to see us out in the field with our trade show schedule this year. We've got Horner folks at all these places you see on the screen in the Midwest and the South. So join us this summer and this fall at a trade show out in the field. Okay, lots of ways to interact with Horner online at hornerautomation.com, on our YouTube channel, and we're very active on LinkedIn. Okay, next week we have an interesting topic for you. We're going to show you how you can take advantage of the video capability that is present in several of our OCS models and actually do screen capturing of video stills in reaction to a security event. Security is becoming more and more important with machine control, and we're going to show you a very practical approach to solving or at least performing a video security function. Okay, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do some good.